Hello everyone, I'm Vedant Ari Jain and I'm a solutions architect here at Protect AI. And I'm excited to show you Recon, our automated red teaming solution for Gen AI applications. So you know how typically companies conduct manual pen testing maybe once or twice a year? Well, Recon is like having an AI security team that allows you to regularly test your LLM applications for vulnerabilities based on the frequency of your choosing. So right at the top, we can see our key metrics. We've added 5 targets, completed tests on all of them, and run a total of 8 scans. This gives you immediate visibility into your testing coverage. The dashboard also breaks down successful attacks by category, which is crucial for understanding where your vulnerabilities lie. So let me just walk you through what we are seeing here. We can see a few jailbreak attempts, which has been our most frequent finding, with 745 successful attacks out of almost 1,300. There's prompt injection attacks, followed by, most importantly, 23 system prompt leaks, which could really expose your model's core instructions. So in total, we've identified about 2,000 successful attacks across all categories. And this kind of detailed breakdown helps security teams prioritize their remediation efforts. And then at the bottom, you can see our scan history. Each scan shows its progress and current status, giving you real-time visibility into your testing operations. The dashboard is really designed to give security teams both a high-level overview of what they need for reporting, as well as detailed insights required for effective remediation. So let me dive deeper into how Recon actually conducts its testing, because this is one of the ways we really differentiate ourselves from traditional adversarial testing tools. So before you can run a test or a scan, you need to first define a target. This is the first step in creating an automated red team campaign and is normally gated by an entry point or an API endpoint into your LLM application. So let me show you how to set up a target in Recon. Firstly, we need to provide a target name. This helps you track different applications or endpoints you're testing. Then we need to specify which LLM or application or endpoint are you going to connect to. Recon supports various major LLM platforms and deployment methods, and this list is continuously growing. So we have OpenAI for GPT models, Hugging Face for open source models, REST API for custom deployments, streaming targets for processing incrementally generated tokens, and Databricks for enterprise ML platforms. So for this setup, let's choose a Databricks target. And the configuration happens in 3 simple steps. Step 1 is authentication. We have 2 authentication options. There is access token authentication, which is great for quick setup and testing. And then we also have OAuth for enterprise scenarios where you need more robust access control or service-to-service integration. After choosing the authentication method, you'll need to provide the Databricks access token or the OAuth service principal details. And then you provide the workspace URL for your Databricks workspace, and then the model that you're trying to test. And all of this information you can get from your Databricks workspace itself. So next, we'll verify the request JSON structure. The input placeholder that you see here is where Recon will inject its test prompts. And you can also customize the parameters for your LLM, like temperature, top P, max tokens, etc., to match your production settings. And finally, you can tune advanced settings, but for most of the scenarios, the defaults work just fine. And once configured, Recon will use this target configuration to conduct comprehensive security testing against your model. So let's assume that we set up a target, and let's go ahead and create a comprehensive security test. So Recon offers 2 powerful testing approaches that we can use together: our attack library and our agent-based testing. One of the things that makes Recon special is its understanding that the real-world attacks aren't just single-shot attempts. Attackers typically engage in multi-turn conversations, gradually probing and exploring vulnerabilities across an entire session. Think of it like a chess game. Each move builds upon previous interactions to ultimately achieve the attacker's goals. So let me show you in more detail our various testing approaches. So first, we have our attack library. Like I mentioned, this is our comprehensive collection of known attack patterns and vulnerabilities. But unlike static security tools, Recon dynamically adapts these attacks based on specific models and specific use cases. And we are constantly updating this library with new attack vectors discovered by our threat research community. We have 7 different attack categories. And then we have the agent-based testing, or LLM agent-based testing. This is where things get really interesting. So our agents simulate sophisticated adversaries engaging in multi-turn conversations to really test for vulnerabilities and boundary conditions that only emerge over multiple interactions. And finally, we have our human-augmented testing capability. This combines the benefit of automated testing with human expertise. So threat modelers can define custom attack scenarios specific to their use case, add industry-specific test cases, and create complex attack chains that might not be obvious to automated systems. And then let me show you how to also fine-tune these tests. So we have several key parameters here. For breadth, you can specify the range of attack vectors you want to test for your campaign. And for depth, we can control how many turns each conversation takes and the complexity of the attack chains for the application to attempt. The key to understand really here is that we aren't just throwing a bunch of prompts at your model and hoping that something sticks. This is a sophisticated goal-oriented testing that mirrors real-world attack scenarios. And we are testing not just individual vulnerabilities, but how they might be chained together across a session to create more serious security breaches. So let me show you results of some recent test runs. The findings are significant and highlight several critical security concerns. So let's go to an agent-based test first. So looking at the overall risk assessment, this model received an overall risk score of 71 out of 100, which is categorized as high. This indicates substantial vulnerabilities that need immediate attention. So let's first look at how the agent crafts prompts to emulate multi-turn attack patterns in order to achieve attack goals. So here is one goal that we can dive deeper into. And we often see our customers get quite creative with these goals depending on their use case. So let's look at this specific goal and dive deeper into one of the attack vectors. So we can see here initially through this conversation that the built-in guardrails for the model initially decline the attacker. However, when presented with a Morse code-like attack, it was jailbroken into providing exact details in how to be emotionally manipulative. So let's go back and look at another scan. Let's take a look at the agent library this time. So this one got a lower risk score. Out of our testing campaign, we identified 221 successful attacks across these different categories. Some of the concerning ones are the number of jailbreak attempts with almost over 70% success rate, which means that the model's bespoke guardrails or safety guardrails are significantly vulnerable. There are quite a few safety violations as well. And most importantly, there are 3 successful evasions out of the 28 attempts for system prompt leak, demonstrating that some resilience, but still concerning vulnerability to obfuscation techniques. Also, let me highlight some of the critical attacks that we uncovered. There were multiple successful adversarial suffix attacks that tricked the model into providing harmful content, and several attempts of extracting information about illegal activities. So based on these results, the security team can recommend focusing on 3 immediate areas: strengthening the model's jailbreak resistance, enhancing safety filters and content monitoring, and implementing stronger prompt injection defenses against adversarial suffix attacks. And then finally, to help align our findings with established security standards and compliance requirements, we also provide a view of how these vulnerabilities map to industry standard security frameworks. Our testing evaluates vulnerability across 5 different frameworks. So we have OWASP 2025, which is the newest framework specifically designed for LLM applications. We have the older OWASP 2023. We have the MITRE Atlas, which is the adversarial threat landscape for AI systems. And then we have the NIST AI risk management framework, which emphasizes broader risk categories, including reliability, safety, and fairness. And then recently, we also announced our mapping with Databricks AI Security Framework 2.0. So with the combination of this bar chart as well as this radar chart, you can see how the successful attacks distribute across these different frameworks. This mapping helps us understand which security standards are more relevant to current vulnerabilities, where your model's security posture needs strengthening relative to industry standards, and how to prioritize remediation based on compliance requirements. So this multi-framework analysis ensures that we are not just fixing individual vulnerabilities, but building comprehensive security that aligns with established industrial standards. And the best part is that you can schedule this as and when you need against your application, so you're not waiting for an annual pen test to find critical vulnerabilities into your application. So that's it from me. Thank you so much.